Hello everyone, my name is Kobe Mike. I am a PhD student here in the Faculty of Education. My research is about data science education under the supervision of Professor Orit Khazan. My guest lecture today is going to be a little bit different from previous guest lectures. I'm not going to talk about my research. I'm going to present you an introduction to machine learning. I hope that these lectures will help you to clarify what is machine learning and what types of machine learning exists and what is the connection between machine learning and learning analytics. So let's start. So let's start with an example, and the example is not from learning analytics. The example is from fraud detection, and say we have to detect whether a credit card transaction is fraud or legitimate, and we have the following transaction. Abram bought a refrigerator at 8 a.m. The item price was 3,000 new Israeli shekels. And we have to decide whether this is a legitimate transaction or a fraud. So first, let's formalize a little bit the representation of the problem. And we have here our feature vectors, and the feature vectors are who is the buyer, what did he buy, what was the amount, and what was the time. So we have here four features, and we need to build a classifier, and this classifier has two outputs. You can say that this is a legitimate transaction, or it can say that this is a fraud transaction. And we have to decide what is this question mark here and how can we decide. So here is one possible solution. We can say that if the price is greater than 10,000 shekels, then this is a fraud, and if the price is less than 10,000 shekels, then this is okay. And this number here might arrive from domain experts who knows that the statistics of, and this number here, the 10,000, might come from domain experts who know what are the buying habits of people. And we can see systems like that working everywhere, also in education. And we know that if you want to go to university, you have to take a psychometry exam. And if your grade is greater than something that you can learn in the university, and if not, then not. So those kind of systems are quite popular. So this is a rule-based system working with a rule-based algorithm. And the question is there another approach? And why do we need another approach? Because rules-based algorithms are not always successful. We need domain experts tell us what are the rules, or maybe we are the domain experts and we have to think about the rules. And you can think of problems that it's just maybe too difficult to decide on the rules. Let's say you have to give a computer an algorithm that will distinguish between a photo of a cat and a photo of a dog. You can try to think yourself what kind of rules you can give the computer for this classification problem, and maybe it is just too complex. So we need a different approach, and the new approach today is learning algorithms. And those are algorithms that learn the decision rules based on examples or on feedback. I will elaborate on those learning algorithms, also called machine learning. So we have several types of machine learning, and the first type is supervised learning. And supervised learning, it means that we give the machine the examples together with their labels. So, for example, for task of classification, we can give the algorithm many photos of cats and many photos of dogs, and we will give him the label. This is a photo of a cat, and this is a photo of another cat, and this is a photo of another cat, and those are photos of dogs. And the task is going to be given a new image. What is its classification? Is it a dog or is it? And for this task, we can take, for example, from learning analytics, is the classification whether a student will succeed in the course or not, or succeed in a specific task or not. The second type of supervised learning is regression, and for regression we don't have just a categorical variable that we have to predict. We have a number that we have to predict, and this can be a price of a house, or it can be a final grade for a student, and here we have to predict the number. Third type of machine learning is unsupervised learning, and for unsupervised learning we don't have a training example, and we ask the algorithm to find clusters of similar items. For example, we can give him a lot of academic papers or a lot of books, and the algorithm will try to predict what are the groups of books or papers we have in our corpus. An example for learning analytics can be a corpus of students' homework, and we want to cluster them to different type of errors that students are making, and this way we can find out similar works with similar errors. And the last type of learning is reinforcement learning, and the task here is agent control, and this means that we have an agent that is learning while it is working, and we can see, for example, Google Ads, and Google is trying to match for us the best ads they think that we have a probability that we will click on, and while they give us the ads, they are collecting our ad click data, so they are watching which ads we click and which ad we do not click, and using this information the agent can learn better which ads we need. And if you think on application for learning analytics, we have systems today that give students several questions, and based on how we did in those questions, the agent give him the next task, and based on how well he did on the next task, the agent will give the students the next task, and in this way the agent can optimize the learning. Think that a teacher would not have to say to the entire class, solve exercises 1 to 20, but the computer will watch how the student is doing on exercises 1 to 4, and will give the exact exercise that each student needs, and not everyone will have to solve everything, and we can build like that personalized learning. So I already defined the classification. We have to predict a class or a category, a cat or a dog. Is a tumor benign or malignant, and or credit card fraud. And let's see now what does it mean learning from examples. So we have our vector of features. Abraham bought a refrigerator. It cost 3,000 Israeli shekels at 8 a.m. and we have our prediction task. And what we are doing is we are looking on a dataset of other transactions, and for each transaction we know whether it was a fraud or a legitimate transaction. And how do we know it? And, well, this is hand-labeled dataset, and we need a lot of labeled dataset. And we take all this example and we train a model, and the model is being trained on this dataset, and we are not going to get into the details of how do we do this training, but the meaning of learning from examples is that we have a lot of labeled examples, and our algorithm is learning from this dataset, and it produces the model, and the model is used for the prediction. Here are some examples of algorithms: logistic regression, k-nearest neighbors, decision trees, neural networks, and deep learning. are all types of classifiers. For regression, we are going to do the same, but this time we are going to predict a number and not a category. And in the example here, we want to predict how much Abraham is going to spend on his travel to Canada. And we have a dataset, of many other travels abroad. Some of Abraham, some of other people, and we have here the destination, how many persons, and how many days, and what are the travel expense. And again, using those examples, we train a model, and using this model, we can predict what is the expected expense of Abraham abroad. So you can see here regression under supervised learning, and linear regression is the most famous type of regression. The third type we talked about is clustering, and here we try to find groups based on similarity. And this is something Netflix is doing, for example, to cluster customers and to give recommendations based on similar customers. If Netflix wants to find what is the most recommended movie for me, they will see who are similar customers who watched videos similar to what I've already watched, and they will recommend videos that others watched, customers that are similar to me. So we have our customers, and we know what kind of movies they watched, and the algorithm is building us clusters, and we don't really know what is the meaning of each one of the clusters. All we know is that Abraham is similar to Sarah in his preference, and Isaac and Jacob are similar in their preference, and Rebecca and Rachel are similar in their preference, and we can give recommendations for Rebecca based on what Rachel liked. So this is clustering, and one famous clustering algorithm is k-means. And the last type we talked about is the reinforcement learning, in which the agent is doing something in the real world and is learning from the results that he gets. So this is the map of machine learning, and I hope it helps to clarify the world of machine learning and what types of application we have for machine learning. And looking forward to meet you in the class. Bye.